and welcome to a new video series on Google Earth Engine. Today I will try to discuss a very important topic. This topic is the area calculation on a single images using the Google Earth Engine. Mainly in this task I will try to show you how you can easily calculate the change detection to quantify what change from one year to the next. Okay, so mainly in this, here you can see here I already put a Landsat imagery. Then I simply filtered the image for the year of 2015 as well as also filtered the year of 2020, and I can simply get the calculate the NDVI. Okay, so mainly in this code I will calculate the NDVI images year of 2020 and year of 2015. Okay, I simply calculate the NDVI year of 2015 and NDVI year of 2020. Okay, so now I want to calculate the change detection between this time, between these two time. Okay, so I can simply do it. I want to take from a variable. For this I simply take a variable and I can give this variable name is image difference. I can simply use the image diff, and then I simply call the variable name of NDVI 2015. Then I simply use here the subtract function, subtract with NDVI 20. Okay, so it's indicating the change detection. Okay, so now I want to show this change detection in map interactive view. So for this I simply use the map dot add layer function and I put all of this argument one by one. This is my object, I simply put here, and then I simply call here the visualization parameter. So here I already included the visualization parameter. I simply copy and paste here, and I also gave this layer name is the change detection. Okay, and when I simply click to the run, then you can see your a new layer will be opened, and this is the difference between the NDVI 2000 year of 2015 as well as NDVI year of 2020. So now you can see a new layer will be opened, and it's indicating the layer is the change detection between the two time frame. Okay, so I hope you understand this part, and next part is that I want to calculate it how many NDVI plays will be available. Okay, so we can easily do it. So for this you need to make a NDVI threshold. Suppose I can take a NDVI threshold in this time. Suppose I take a variable and then I simply put here the variable name is threshold. You can use any variable name. I use the threshold and I can give this threshold is 0.1. I want to take the filter of this between this value of NDVI, and I want to calculate the how many NDVI land will be available in this time between the change detection, after the change detection. Okay, so for this I can simply use a variable. Suppose I can simply use this variable name is change, and then I simply use here the image difference. So you can see this is our image difference. I simply call this image difference, and then I want to use here the less than equal. I simply use here the LTE, less than equal between our threshold. I can simply use here the threshold, it is the 0.1. actually it will be less than equal 0.1, or I can also use here the OR function and define here the image difference, and it will be greater than our threshold. I simply copy this threshold. Okay, now I want to get this all of this NDVI value which will be less than equal or greater than equal between this threshold 0.1. Okay, so I can get this result from here, and then I simply use here the self mark function. Okay. So now it will be indicating the changes, okay, according to this threshold value. Okay. So I can get only for those NDVI value which value will be less than equal 0.1 or greater than 0.1. Okay. So I can get this value. So now I want to calculate it, how many land will be available this NDVI 0.1 less than equal 0.1 or greater than 0.1. So I can simply do it. So for this I can take a variable, this variable name I can give, this variable name is pixel area. Okay, you can use any variable name, it's totally depend on you, but in this time I simply use this pixel area. I simply call this, change this variable name and paste here, and after this I can simply multiply it with ee dot image dot pixel area. Okay, I can simply use this function, and this function calculate the pixel area in the meter square. Okay. So now I want to get this result. So for this I want to calculate this area from here. So for this I take a variable, and this variable name is, I can give this variable name is area, and after this I simply use here the reduce region function so that I can easily calculate this area. So I can simply use here the reduce region. Okay, I can simply use the reduce region, and this is the all of this argument. I put all of this argument using the dictionary function and put all of this keyword and key value one by one, so that I can use here the curly bracket between two side, and after this I can simply use the reducer. I want to get all of this mean value, so I want to get the all of this mean sum value. Okay, so I simply use here the ee dot reducer dot sum function. So that's why it will be calculated the all of this NDVI value, and it calculate the total area of NDVI value between this 0.1 range. Okay, so geometry, in this time geometry will be point. I can simply use here the point, and then scale. This is the Landsat satellite imagery, so that we can use here the scale is 30 meter, and other argument is not needed for this time. I simply remove all of these things, and max pixel it's needed for this time. I simply use the max pixel, and it will be, I can use here the 1 E10. Okay, and tile scale it's not needed for this. I simply delete all of these things. Okay, so for this I use here the printing function, and then I simply use here the print function, so that I want to show how many images or how many land will be available for the total NDVI between this 0.1 range. I can simply use the print function, and then I simply use here the area. This is my variable name, and when I simply click to the run, now you can see here your console tab will be opened, and in this time you can see here how many images or how many land will be available, the NDVI between this threshold. Okay, so in this time I can see here this is the only for 899.22 square meter square. Okay, so now you can see here this result will be showing the meter square. So now you can see the total NDVI value available in this land. This is the 899.22 meter square. So now if you want, you can also convert this square meter to hectare. You can easily do it. So just you can take a variable. I can give this variable name is area hectare. I can use the area hectare variable name. You can use any variable name. It's totally depend on you. Then I simply call the ee number function, because it needed for the when you define any number, ee dot number function. Then I can simply use here the area. This is our variable name, and for this area I simply get the NDVI value. So I simply use here the get function, then I simply put here the NDVI. This is my value, NDVI value. Okay, and after this I simply use here the divide function. I divide it 1 E10 1 E4. Okay, so it means the 1 into 10 to the power 4. So I can simply divide it, so that I can easily convert this result from square meter to the hectare. Okay, so now I simply use here the print function, and then I can get the simply call this variable name and paste here, and I can simply click to the run. So now I can get this result in hectare. Okay, so now you can see your console tab will be opening. So now you can see it's only for the 0.0899. okay, this is the hectare unit, and we can also calculate it the NDVI. This is the meter square unit. Okay, so I hope in this tutorial you can easily understand how you can calculate the sense detection, and how you can observe the sense detection, and how you can calculate it how many NDVI will be available between this threshold. Okay, so here I simply use here the 0.1. okay, so that's why I can say that this 0.1 NDVI value available total 899 meter square land in this particular region. Okay, so I hope you understand, and if you have any question then you can ask me in the comment section. I will try to answer all of this question, and if you want you can also join our the beginners 5th batch courses. So this course will be start on the 16, 17, 18 November. So if you want you can enroll this course, and just I will give all of this information in my this video description, so that you can easily join our video training classes and get the all of these things, and you can easily understand how you can easily start the Google Earth Engine and do any remote sensing analysis very quickly and efficiently. Okay, so thank you for watching this video.